Now, let's continue with our rational numbers. How are we going to add or subtract rational numbers or fractions that have different denominators? All right. So, in this case, we will have, if we have unlike denominators, our goal, remember, we can only add fractions that have the same denominator. So if they have different denominators, we got to think of a way to make them the same denominator. And for us to be able to do that, we're going to use our skill on finding the least common denominator or the least common factor. So let's have this example here. We have 3 over 4 plus 1 over 6. We cannot add them because they have different denominators. So how are we going to do this? Okay. So what we can do is we are going to find an equivalent fraction in such a way that the denominator will be the same. So if we are going to think what number could easily be divided by 4 evenly and also by 6, okay? And you can also use your factor tree if you want. But given 4 and 6, the smallest possible number that can be divided by both numbers is going to be 12. All right? So, in this case, we are changing our original fractions into a fraction with a denominator of 12. So, how are we going to find their corresponding numerators? So, try to think of it. How can 4 become 12? Well, we had to multiply 4 by 3 to become 12. And so we also multiply 3 on our numerator, which means our numerator now is going to change to 9 over 12. In the case of 1 over 6, 6 can become 12 by multiplying by 2. And so we apply the multiplication of 2 to our numerator. So this is now 2 over 12. And as you can see, we needed to add them. Can we add 9 over 12 and 2 over 12? Yes, because now they have the same denominator. All we needed to add is their numerators. And so that would be 9 plus 2, which is 11 over 12. And that is already in simplest form. All right? So that is how we can work with unlike denominators. So whether it's addition or subtraction, we need to find an equivalent fraction in such a way that that fraction will be a common multiple of the two given denominators. All right. One thing new that you will be learning in this topic is what we call as the density of rational numbers. So when we talk about density of a rational number, we are going to find a number that is exactly right in the middle of two given rational numbers, okay? So it's pretty much like the midpoint, okay? It's got to be midway. What number is exactly in the middle of this fraction and this fraction? So let's have this example, all right? We have 1 over 2 and 3 over 4. So step number 1, add the fractions, okay? That is the first step, add the fractions. So what we do here is we have 1 over 2 plus 3 over 4. We cannot add them because they have different denominators. So we need to change them in such a way that the denominator is the same. Well, as you can see, 4 can be divided by 2. So we can use 4 as our common denominator. 1/2. So 2 to become 4 will be multiplying by 2. So that's 2/4. 3/4 stays the same. And so when we add this, our sum is 5 over 4. All right. So the next step, after adding, okay, we need to find the quotient by dividing it by 2. All right. So it's pretty much like getting the average. We add the two numbers and then we divide by 2. Okay, because we're looking for the middle by 2. So this is now going to be 5 over 4 divided by 2. Now, what is the rule when we are dividing? Okay, 5 over 4 remains the same. The division will change to multiplication, and our divisor, which is 2 over 1, will now change to its reciprocal, which is 1 over 2. And now we can do our multiplication. 5 times 1, which is 5, and then 4 times 2, which is 8. And so our final answer is 5 over 8. So what does this mean? 5 over 8 is exactly right in the middle of our fractions 3 over 4 and 1/2. So between 1/2 and 3 over 4, 3 over 4 is bigger. So right in between those two is what we call as the 5 over 8. So one common application of rational numbers is usually when you are preparing food. And so we always have a recipe, but then that is for a specific number of servings. So when you have to adjust the number of your recipe based on the number of servings you will need, so pretty much the formula will be the amount of the ingredient needed is going to be the desired serving size over the recipe serving size, and then multiply it by the ingredient amount based on the recipe. So let's have this example for this one. Okay, so let's say we have a chocolate chip recipe for 5. So the recipe is for 5 dozen cookies, and it requires 3/4 cup of sugar. Now, what if you need to create or to make 8 dozen of cookies? So how much sugar are we going to need? Okay, so if we're going to follow the formula here, the amount of sugar that we need will be equal to what is our desired serving size. Our desired serving size based from the problem is 8 dozen. So 8 over the recipe size is actually 5 dozen. Okay. And then, looking at our formula, what was the ingredient amount based on the original recipe? Now, the original recipe uses 3 over 4 cups of sugar. All right. So, if we are going to do our multiplication here, so this is going to be 8 over 5 times 3 over 4. We continue our multiplication. This is going to be 24 over 20. All right. And we can simplify this to become, both of them could be divided by 4. This would be 6 over 5. And 6 over 5 being improper, you can change it to a mixed number, which is equivalent to 1 and 1/5. So from here, if you would like to create 8 dozen of chocolate chip, you will be needing 1 and 1/5 cups of sugar. So that is one application on how you can use rational numbers in real life. Thank you.